The second part of chapter 1.5, at least the way we deal with it, is the Intermediate Value Theorem. And to think about this, let's think about an analog speedometer. We've got the world's best drawing of an analog speedometer in a car here. Let's say you look at the speedometer and it says 60 miles an hour. Well, let's say 40. And then let's say you look again 20 seconds later. In the meantime, you're watching out for pedestrians and stuff, right? And it says 70, let's say, well, that's a bit much. Let's say 50 miles per hour. Here's the question. Was there some time in between the two times that you looked at it when the speedometer read 43 miles per hour? And when we say 43, what we mean is 43.000000, etc., all zeros. Do you think you could guarantee that there was some time between those, the first look and the second look, when the needle pointed exactly at where 43 would be? I'd say yes, we can guarantee it. At least down to the level of atoms and stuff. Was there some time in between those 2 points when the speedometer read 51 miles per hour? What do you think? Can we guarantee it? Can we guarantee it didn't happen? I'd say it might have happened. We can't rule it out, but we also can't guarantee it. So that's one situation to think about. Let's think about another situation. Let's say you've been thinking of buying some item on some online website and you've been tracking the price. Let's say day one, the item cost maybe $100. Day two, maybe it cost $90. And that still wasn't enough of a discount for you, so you waited, and on day three, it cost maybe $70. Would you say there was a time between day one and day three when it cost exactly $75? And when we say 75 here, we mean 75.00000, etc. Do you think you can guarantee that? Have you ever seen a price tracking graph for online sales? They're pretty interesting. Maybe I'll go pull one up. Here's a price tracking site called Camel. I have no idea how it got that name. But here I've asked it to show the price track of a common calculus textbook on Amazon. Here's the function it shows. Now this is from 2014, 2015 to now. We could zoom in to a closer time span. And when it's showing this drop, that doesn't work as a function, right? That would violate the vertical line test. So I think what that means is it saw a value up here, and then the next time it sampled, it saw a value down here. It's kind of interesting to show the third-party sellers and the third-party used sellers as well. So this is sampling fairly often. The graph I showed on my paper and pencil thing was just sampling a few times, like once a day or something. But let's go back and think about that. So just based on this graph, was there a guaranteed time point in this range when the price was $75, which is between the 70 and the 100? I think we'd say maybe there was, but we can't guarantee that there was. So what's the difference between this situation and the analog speedometer situation, mathematically speaking? Would you say that one function is continuous and the other one wasn't? So based on that and the idea of, can we guarantee there was a time point between our start and our end where we crossed some value in between the upper and lower value, we're going to define the intermediate value theorem. Or IVT. I'm going to write out a statement of it, but it might not be the world's best statement of it, so think about how we might need to improve it to make it true. So I'm going to say a function between a f of a and b f of b hits every y value between f of a and f of b once on the x interval a to b. So what we're thinking about here is a graph where we have some start and stop point and some function value here. This is f of a. Say here's f of b. And the function, maybe it's doing something like this. That's slightly nonlinear. And we're thinking about some other y value. So we'll draw that in with the dashed line. So can we guarantee that this function between this point and that point, those 2 points, hits every y value between this upper y value and this lower y value once on that interval? So think about how we need to improve this statement. Well, what could we have drawn that didn't work that way? Our price graph up here, right? It could have gone like over here and then jumped down here. And that's not like our analog speedometer, which was reading, which couldn't possibly jump like that in an instant. So what we need to think about here is continuous. It needs to be a continuous function. So that's one issue. What else can we say about this? Can you imagine some other function that goes between a and f of a and b and f of b and is continuous, but doesn't just hit every y value once? Well, you might imagine a function that does something like that. It hit that dashed line y value more than once. So how else can we change this definition? We could say at least once. So it might feel like the intermediate value theorem is obvious, and it kind of seems obvious, but what it's really getting at is that the real numbers don't have any the real numbers meaning the rationals and the irrationals together. Don't have any gaps like the integers or just the rationals do. So let's write that down. So it seems obvious, but only because the real numbers don't have any gaps. Like the integers or just the rationals have. That's the intermediate value theorem is not true if our x-axis is just the integers or just the rational numbers. The book says that the intermediate value theorem is used to find roots of functions, places where the function crosses the x-axis, which is kind of true, but it's not like the intermediate value theorem tells us exactly where. It just guarantees that there is a crossing somewhere if you have one of these points above the y-axis, above the x-axis, and the other. It's used in the sense that it guarantees something exists, but it doesn't actually help you find it. So let's write that down. So the book and lots of calculus books then go on to talk about the bisection method for finding roots of functions, which is fine if you have to do it by hand, but we basically don't have to do it by hand these days because we have computers. So a nice Excel skill is called goal seek, where you can tell it, here's a cell and I want it to be equal to this value, like 0 or some constant, by changing some other cell, the x value. And you can find videos on YouTube on how to do that. So that's a handy skill every now and then.